In this video, we're going to talk about vapor pressure. So in this chapter, we've been talking a lot about gases. We're going to look at an example where we've got, let's say, a closed system, and we have some molecules that are in the liquid phase, and then we have some molecules that are in the gas phase. So it is these gas phase molecules, or the vapors above that liquid phase, that exert a pressure, and that pressure is called the vapor pressure. So in this figure from your book, we're looking at two things here. So we have a liquid phase again, okay, and then above it is our gas phase. And you have in red evaporation occurring. So in evaporation, you have a liquid molecule going to a gas phase molecule. Then they have a condensation arrow, and condensation is when we go the opposite direction. So a gas phase molecule is going back into the liquid phase. So what happens is we have these molecules, and some in the liquid phase are going to the gas phase, some in the gas phase are going back to the liquid phase, and if we let the system sit for long enough, it will come to equilibrium. And at equilibrium, the rate of evaporation is equal to the rate of condensation, and so that is when the vapor pressure is established. So I'm going to draw our beaker again. So we've got liquid, gas, and this is a closed system. So it has to be closed so we can get pressure to build up in there from the gas phase. If they could escape, they would just go off into the atmosphere. So if you have something that has a really low boiling point, it might have a high vapor pressure or a lot of molecules in the gas phase at atmospheric pressure. So ether is an example of a molecule with a low vapor pressure. So the boiling point of ether is 35 degrees Celsius. So at atmospheric pressure, there's a lot of ether in the vapor phase. And because ether has a distinct odor to it, we can smell it. So if we had a beaker of ether, we would smell it, and that's because a lot of it is in the vapor phase. So when atmospheric pressure equals vapor pressure, then you have the boiling point of a liquid. So at the boiling point, the molecules are going from a liquid to a gas, so they're going to be in the vapor phase. So the lower the boiling point, the higher the vapor pressure is going to be, typically. You could have a molecule with a very high boiling point, and the vapor pressure would be very low. So at room temperature and atmospheric pressure, it's going to be almost all in the liquid phase and very little in the vapor phase. So to wrap up, we'll draw our picture again. We have a liquid and a gas in a closed system, and the pressure exerted by that gas on the liquid is the vapor pressure. So for some molecule that has a lot of molecules in the gas phase, it will have a high vapor pressure, and for a molecule that has not very many in the gas phase, mostly in the liquid phase, it has a low vapor pressure.